my God. This is not good. Please, dear God.
In May of 2013, a massive tornado devastated Moore, Oklahoma. It was classified an EF5, the highest rating on that scale. It caused over $2 billion in damage to 30,000 people and left 23 dead. The summer saw heat waves all over Japan, with a record high temperature of 41 degrees centigrade. Many unusual weather events have occurred in recent years, and man-made global climate change is believed to be the cause. There are some who are boldly rising to face this problem. In October 2013, a ceremony for the Blue Planet Prize was held in Tokyo. The award is given to individuals who make outstanding contributions to solving global environmental issues. Considered as prestigious as the Nobel Prize in environmental circles, 2 awards have been given each year since 1992. One of the 2013 recipients is Japanese meteorologist Dr. Taroh Matsuno. He has helped predict and explain climate change and furthered the world's understanding of it.
The world's climate is an important new issue. It's not just the weather report, but a more long-term look at changes in weather and the problems that causes. I will continue to work so that we can understand these problems.
The other winner was Dr. Daniel Sperling from the US. His research into sustainable transportation systems has helped the progress of environmental policy.
We need to reverse trends and patterns of the past 100 years. It's not easy, but with great effort, we can recover our healthy blue planet.
These individuals are doing all they can to help protect our home, our blue planet. This program is made possible by the Asahi Glass Foundation. The Japan Agency for Marine Earth Science and Technology. Blue Planet Prize winner Dr. Taroh Matsuno has researched weather for 50 years. While most researchers go to the US or Europe, Matsuno chose to stay in Japan and spur on development. At almost 80 years old, he still runs ahead of the pack, leading a team of younger researchers. His current target is the relatively unknown tropical zone.
If we don't study the tropics, we don't have a clear picture of much of the planet's surface. The equatorial zone's climate affects half the Earth. We're still missing that data. We don't understand the mechanisms working in that part of the world.
Matsuno and his research team have successfully developed a system that has gathered worldwide attention. NICAM is an atmospheric model that simulates clouds moving across the entire planet. It could more accurately predict the movement of clouds over the tropics, something that had never been done before.
People have been trying to do this everywhere, but we're the first to create a system precise enough to actually use.
As a child, Matsuno loved science. He first encountered meteorology when he was a junior high school student just after World War II.
We went to a weather station on a class field trip. While I was there, I happened to drop a fountain pen And when I went back to pick it up, a person there explained weather maps to me. It was right before a typhoon came, so I learned that drawing a weather map can provide really useful information.
When Matsuno got home, he headed straight for his desk.
This is a notebook in which I drew weather maps over summer breaks in junior high school.
At the time, weather reports were broadcast over the radio. However, they weren't well understood by ordinary people. Even so, Matsuno made a habit of drawing weather maps on his own, based on the daily reports he heard.
Back then, the U.S. military would assign female names to typhoons in alphabetical order. I still remember them. C would be Carmen, Della, and then Elaine, Faye, Gloria, Esther, Irma, Judith, Kitty, Lisa, and so on.
When he entered university, he went directly into meteorology. There, he met someone who influenced his research greatly. His name was Dr. Shukuro Manabe, winner of one of the first Blue Planet prizes and a pioneer of meteorology.
Most people would learn what elite professors were doing overseas and base their research on that. But he did something different. He was doing rain forecasts that the U.S. wasn't doing yet. His style of doing his own thing fit with my own attitude perfectly. So I'm very grateful to him.
Rather than chase world trends, Matsuno studied what was important to him. That conviction produced great results. In 1966, he published a thesis entitled Quasi-Geostrophic Motions in the Equatorial Area. In it, he demonstrated proof of the existence of tropical waves near the equator. These waves were later observed and formed the foundation for research into El Niño, a phenomenon said to have been caused by global warming. Coincidentally, around that time, air pollution, ozone depletion, and other issues were starting to be recognized as global environmental problems. In that arena, Matsuno stood out. Not only was he a leading researcher into global climate change, but he also presented data predicting climate change at international conferences, making great contributions. Matsuno was working to solve global environmental problems, but he had a tremendous obstacle to overcome. Most weather research was done in the temperate zones of Europe and North America, while almost no research had been conducted in the tropics.
Tropical weather is very different. In temperate zones, atmospheric currents control the weather. But in the tropics, clouds are the cause behind the currents. So clouds are the key.
What caught Matsuno's eye was the Madden-Julian Oscillation, or MJO, a great mass of clouds found in the tropics. Some say that it holds the secrets to understanding global climate change. This is a satellite view of the MJO. In 10 days, it travels from the Indian Ocean to Southeast Asia. A week later, it grows even bigger to be over 10,000 kilometers across.
And what's more interesting is that these cloud masses themselves sometimes become typhoons.
That isn't all the MJO causes. It also affects faraway regions, causing droughts, heavy rains, and monsoons all over the world.
We don't fully understand the MJO. The biggest problem is current meteorology doesn't work for it, so we're trying to change our way of thinking.
Matsuno decided to create an entirely new cloud simulation system that could analyze each of the small clouds making up the MJO. Up until then, weather forecasts and research had divided the globe into a grid based on latitude and longitude and gathered weather data from individual blocks on the grid. However, each block covers roughly 100 kilometers, and each cloud is rarely bigger than 10 kilometers, making pinpoint estimates impossible.
Dividing the world into equal areas is important. And one method is turning the surface into an icosahedron, which chops it into 20 triangles. You can then divide those triangles 2, 3, or 4 times, or more. At 11 times, one side is just 3.5 kilometers long. We've decided to convert to this system.
Matsuno divided the surface into a mesh with segments smaller than 10 kilometers using a different equation. Being able to analyze individual clouds allowed researchers to make accurate predictions.
I was concerned that if we didn't get results, our younger researchers would have trouble finding jobs or writing papers. I worried and worried, but our calculations found success 3 times faster than we'd hoped.
It was a challenge many thought insurmountable, but this Earth simulator helped them complete the task. It was the world's fastest supercomputer in 2002. They thought the theoretical model would take a decade to produce, but this machine did it in a fraction of the time. Thus, 2005 saw the birth of NICAM, the only atmospheric model able to predict rainfall variations in the tropics. The world was stunned. This is Dr. Tomoe Nasuno, one of the people behind the project.
3.5 キロって全球っていうデータが出てきた時はもうゾクゾクして毎日毎日夢中になってそのデータ解析しました。
On the left is a satellite image. On the right is an image from NICAM. You can see that the simulation has accurately produced cloud movements seen in the real world. Thanks to NICAM, the life cycle of a typhoon can be predicted 2 weeks in advance. But models alone are not enough to understand the MJO. They need to be compared to real-life data. Matsuno's team headed to equatorial waters to perform intensive observation in a place no one had before. They would send their findings back to the NICAM development team for greater accuracy.
今ここに見えているのがドップラーレーダーシステムといって海洋の上にできる雲、雨を測る装置です。
A Doppler radar, a device rarely installed on a ship, allowed them to observe raindrops in the clouds over the Indian Ocean. The team succeeded in observing the formation of the MJO for the first time in the world.
自分しか知らないと思って非常にワクワクしますし、この成果を早く出してみんなに知ってもらいたいな、生活している人たちのために役立つと信じてやっていますので、明日の天気がどうなるかどうか、来年どうなるっていうのに対しても貢献するというふうに思ってやっています。
Matsuno's team is now working on a model of not only the atmosphere, but also its interactions with forests, plankton, and other living organisms. This simulation shows changes in temperature through different periods. It predicts that if we continue to release carbon dioxide at the same rates as today, we'll see an increase of 5 degrees centigrade by the end of this century.
例えばこれが
Here is an example of a simulation with fairly strict global warming controls. This is what it looks like later. It's an average of 2 degrees hotter from the previous image. If we continue on our current course, we'll end up like the first image. But if we work hard, we'll have a better world, and I want to share that message.
Even 8 years after the success of NICAM, Matsuno and his team continue to lead the world and seek out new challenges. They have succeeded in creating a model using an 870-meter mesh, bringing us a big step closer to understanding global climate change.
Basically, if there's something I don't understand, I want to figure it out. That's important. I hope that young researchers continue to work in that spirit.
The state of California. Outside the state capital of Sacramento sits the University of California, Davis. An unusual village has been recently built on campus. On its roofs are solar panels. They even cover the parking lots. And on the windows are curious sunshades. The man who was involved in designing this village is the other 2013 Blue Planet Prize winner, Dr. Daniel Sperling.
What's so impressive about it is this design for it to be zero energy, net zero energy, which means that we use no energy from the electricity grid.
This is the nation's biggest planned zero net energy community. It currently has a population of 2,000 students and staff. Sperling has been leading the world in research into sustainable transportation systems since 1991, when he founded the Institute of Transportation Studies here at UC Davis.
This is a real commercial business. The university owns the land, but the developers need to make a profit. So this is not a subsidized thing. There's nothing high-tech about it. It's just doing simple things in a logical way. So this is a model. This can be used, and we expect will be used. This model will be used many other places.
Sperling has published a variety of works and has constantly warned the world of the impact of transportation on the environment. But he is perhaps best known for his ability to build bridges between scientists, government, and businesses to create better environmental policies. He was born in 1951 on a farm in upstate New York. His parents helped instill in him an incredible appetite for knowledge.
I think very differently than most people about the future. Even though many people say I'm a visionary, the truth is I think about pathways of change. I think, how do I move forward? Me as a person, or the world, or the research I do, how do we move in the right direction? And I don't think so much in terms of what do I want to be in 30 years. I had no idea I would become a professor. No idea.
Upon entering university, Sperling's horizons expanded.
And when I went to Cornell was the time when the world was changing. That was the Vietnam era, when demonstrations, and so I learned about thinking about different people, about politics, about the environment, things I had never thought about. I always wanted to understand, how does the world work? Why are the roads the way they are, cars? Why do people behave the way they are? Why are cities the way they are? And so urban planning was perfect. I grew up on a farm, so in many ways it's funny because I grew up on a farm, but I wanted to study urban planning.
Wanting to see more of the world after graduating, Sperling left for Central America, working at a government job in Honduras. He says it was there he discovered the path he wanted to take.
Honduras was a very poor country, and many serious problems. So my job was to help improve the cities, plan the cities. And there was not much money, and there was actually very little knowledge. We did not know what people wanted. Did they want cars, buses? How do we design a transportation system for them that was good for them and also low cost and good for the environment? So I learned how complicated the world is.
Realizing the deep connection between transportation and urban planning, he returned to the U.S. to enter graduate school, researching alternative fuels and the environment. At the time, air pollution was at its worst in the U.S., particularly in California. Sperling spent his days studying relationships between transportation, the environment, and energy. He has spoken of the importance of sustainable transportation in solving environmental problems ever since. Some in the automotive and oil industries have opposed his efforts. However, Sperling found a way to appeal to and sway his opposition. He decided to conduct market research and analyze consumer behavior through his own institute and provide that information to companies. He scientifically explained the benefits of plug-in hybrids and next-generation vehicles and pushed for new innovations and technology. During his time as governor, Arnold Schwarzenegger appointed Sperling to the transportation seat of the California Air Resources Board. He was involved in designing a policy which required oil companies to cut greenhouse gas emissions 10% by 2020. It was a revolutionary regulation that was based on scientific principles.
We develop relationships with individual legislators or the staff for the legislators. We develop relationships with the government agencies, the Environmental Protection Agency, Department of Transportation, Department of Energy. And then we also introduce them to industry people because we have, and environmental people. So we have many connections. So we bring them together to help develop a better rule or better policy. And it's really a very old-fashioned idea. It's all about relationships.
With his unique ability to bridge people in different fields, Sperling has been contributing to making the world more sustainable. In December 2013, he spoke at a symposium at UC Davis. Listening intently in the audience were decision-makers from the automotive and energy industries, as well as the government and academia.
We are going to leave most of that. And so here we are, trying to figure all of this out.
His actions have already begun to influence our lives. He started the U.S.'s first car-sharing program with automaker Honda, combining short-term rental vehicles with communication and reservation technologies, which has since developed into a nationwide business.
How do you like this car
It's
sharing?
good, yeah. It's really convenient.
It's contributing to reducing the number of cars and their environmental impact. Honda is now working with Sperling to build smart houses in the UC Davis village. They plan to do a proof of concept, combining solar and geothermal power generation with electric vehicles.
Plug-in vehicle is large appliance, the largest appliance in the house. House energy management should consider that the vehicle portion. That's why what is the optimum control of the energy that we are investigating that.
Environmental awareness is improving among students as well. There are now many bike paths near the campus and space to park thousands of bikes, and that convenience has encouraged more to use them.
How often do you ride on a bike?
Every day. Many times a day, every day. Yeah. You can't really drive into campus very far. Like, this is mostly the furthest you get, and just makes sense. Doesn't cost money to have your bike, you know? Yeah, it's a lot easier. Yeah, for sure.
Even the streetlights are innovative. The LEDs only light up when people pass by, aiming to reduce the amount of electricity used across the campus by 60%. Their efforts continue to expand. Here, a researcher with an engineering background and a design student work together on a device to create energy visibility.
But here's a physical prototype that we actually built. This might be like how much energy a building is using. So if someone turns on a light or like turns on a computer, then you might go and move up a little bit. And then like if you're using too much, this might turn red. So it's like you're being bad.
People's behavior ultimately results in energy use. So if we can provide better feedback loops for people to be able to understand and think about energy and what their choices and decisions mean with regard to energy and emissions, then we think we'll be able to have a big impact.
Today, total emissions of reactive organic compounds and nitrogen oxides from motor vehicles in California have decreased by about 78% since 1975. Sperling has changed the world by connecting scientists with policymakers. He visits Sacramento once a month. There he meets with the California Air Resources Board. The meeting is open to the public and everyone is allowed to speak. Sperling and the other 11 members, including business owners and physicists, represent a wide variety of backgrounds. It is a frank exchange of opinions regarding policy.
Are we looking at some technologies that don't have trade-offs with the greenhouse gas rule?
Yeah, we believe that there are opportunities to achieve lower NOx without compromising fuel efficiency and greenhouse gas standards.
Sperling remains ever passionate.
It's a very transparent, it's very impressive because this is really democracy how it should be. Very transparent. You can see what everyone's thinking, everyone's involved in the decision, all the different factors, all the different interest groups. And that is my goal for the rest of my career, is to focus on this relationship between science and policy and try to figure out how can we bring science to the policy in a better way, more effective way.
Matsuno and Sperling are pouring all their efforts into solving the problem of global climate change. The future depends on the actions of all of us, so that we can provide a beautiful blue planet to our children for generations to come. This program was made possible by the Asahi Glass Foundation